For today, we're going to add in something that your book doesn't cover, which is surface area of polyhedrons and cylinders and cones. They assume that you have this information from previous classes and they can piece it together, but I feel like it's important, so we're adding in a day. Here, I'm just going to go through an example of each. We want to find the surface area of a prism. In this case, each face is a rectangle. So one strategy to do this is to just find the area of all 6 of the rectangles. You have a top and a bottom that are congruent to each other, front and back, and then in the other direction. So what we can do for this is we have 2 rectangles that are 2 by 4. We have 2 rectangles that are 4 by 5. And we have 2 rectangles that are 2 by 5. And we can just add all of that together to get the total area of 76 square centimeters. Now, there is a formula for this because what we're doing here is we're adding a base and a base. We have 2 bases. And then we're adding up these 4 rectangles as we go around. And in every single prism, if they are right prisms, which is what we're working with, all of those faces would be rectangles. And each of those rectangles would have a side length that is one of the sides of the base of the prism. So if we're multiplying each of these bases times 2, what we're doing is we're multiplying 5 times 2, 4 times 2, and then we're doing that again. If we factor out that 2, it's the height of 2 times the perimeter of the base. So in this case, it might be just as easy to find all 6 of the rectangles, but for any prism, we can multiply the base area by 2 and then add the perimeter of the base times the height. So for example, if I look at this prism, if I want to find surface area, I need 2 times the base area plus the perimeter of the base times the height. The base is this right triangle. And again, sometimes it's really helpful not to redraw the whole figure, but just to redraw the base. This is a right triangle with a leg of 15 and a hypotenuse of 25. The other leg is 20. This is a multiple of 3, 4, 5. So my base area is 1/2 20 times 15. So I have 2 times the base area because that'll get the front and back of this prism. And then I have the 3 rectangles that go around the outside. Each of those rectangles has one side that is an edge of the base, and then the other side of the rectangle is the height of the prism. So I'm going to add the perimeter of the base, which is 15 plus 20 plus 25, and multiply that by the height of the prism. I'll put all this into my calculator, and I get that the surface area is 2 times the base area plus the perimeter of the base times the height of the prism. One comment, this is total area. There is something called lateral area, which would just be this part, which is all the rectangles. If you see that at all, it's just the rectangular part, so it's not the bases. Nope, this is what we just wrote, 2 times the base area plus perimeter times height. So if we want to do this for a cylinder, remember cylinders kind of are just like prisms. So they have 2 bases. So we're going to add those 2 areas, but those bases are circles. So we have 2 pi r squared. Each cylinder has an area of pi r squared, or each circle. So there's 2 of them with pi r squared. Plus, we're going to add the perimeter times the height. A circle doesn't have a perimeter. Instead, a circle has a circumference. So we're going to do 2 pi r times the height. So here I have 2 pi. The radius is half of this 10 inches. It's 5 inches. Plus the distance around the circle, the circumference, 2 times pi times 5 times the height of the cylinder. And if you're at all concerned with why this is 2 pi rh, think of if you could cut the cylinder and unroll, like if you took a soda can and you made a vertical cut along the height and then unrolled it, you would get a rectangle. The height of that rectangle would be the 12 inches from here. This length would be the total distance around that circle. That would be my 2 pi r. So this is like finding the area of a rectangle where the length is 2 times pi times 5 and the height is 12. I'm going to multiply all of this together. I get 50 pi here plus 120 pi. Those are like terms because they're both in terms of pi. So I get 170 pi, and my unit here, it's area, so it's square inches. One comment, make sure that you leave your answers in terms of pi whenever possible. So for a cylinder, our formula is 2 times the base area, so 2 pi r squared, plus that lateral area is 2 pi r h. And you can see that in the rectangle again. Now, for a pyramid, we only have one base. So we want to find the surface area of this square pyramid. So the base is a square that's 12 by 12. And then if we look, since this is a regular pyramid, each of these lateral faces is an isosceles triangle. A regular pyramid means that this vertex is directly above the center. Now, what's labeled as 8 here is the height of the isosceles triangle, and that would be the same on every face. So those triangular faces, that height of this triangular face is called the slant height of the pyramid, and we use a lowercase l for slant height. So when we look at slant height, it's the height of the lateral face, the height of those triangles. Here I have one base, so I'm going to find the area of the base, 12 squared, plus I have 4 triangles. Each triangle has an area of 1/2 its base times its height. The base of the triangle is 12. The height of the triangle is the slant height of the pyramid, which is 8. So here 12 squared is 144. And then if I combine all this, I can add that all together and I get a total of 336 square centimeters. Now there is a formula that you can use for this. This first part is the base area. And then the second part, if we look what we have here, I'm going to rearrange these terms. This could also be written as 1/2 4 times 12 times 8. If I change the order, just switch the 4 and the 1/2. 4 times 12 is the perimeter of the base. 8 is the slant height of the pyramid. So what I have here is 1/2 the perimeter of the base times the slant height. A formula that we can use for area, total area, surface area of a pyramid is base area, there's only one base, plus 1/2 the perimeter of the base times the slant height. Make sure that L is slant height, not the height of the pyramid through the middle, but the slant height on the surface. That's the height of the triangles. And again, it has to be a regular pyramid where the vertex is directly above the center of the base and the base is in regular polygon. Finally, a cone. We want to find surface area of the cone. The slant height here is given as 10. And notice that there is a right triangle formed by the radius, the height, and the slant height. That might be helpful, not necessarily today, but over the next couple of days. We want to find the total area. I'm going to use the formula that we just had, base area plus 1/2 perimeter times slant height. But base area of a cone is pi r squared. And there is no perimeter for a cone, there's circumference. So we have 2 pi r in the place of perimeter and the L. And I can simplify this slightly because 1/2 and 2 cancel out, and I get pi r squared plus pi rl. This is surface area of a cone. So in this case, we have pi times 5 squared plus pi times 10 times 5. And my final answer, this is 25 pi plus 50 pi, gives me an answer of 75 pi. My units are centimeters, so area is square centimeters. When you're doing these problems, you can break them down into pieces, or you can use the formulas that were presented as you went.